Welcome to your geometry review. We're going to be going over the August 12th, 2015 Common Core Geometry exam. We're going to be splitting it up into different videos, and each one you could go over a bunch of problems. So there's going to be a lot of concepts covered. Make sure to write down what we're writing down in this video, and you're going to be good to go. So without further ado, let's start going over some problems. Oh, and if it should be pretty obvious, but you should try doing this by yourself first before going over the video. Just a helpful hint. All right, let's get into it. Question number 1, parallelogram must be a rectangle when it's, well, let's just say this. The first thing I'd like to do for all of these, like we do in class, is write down what unit is this from and the topic. Okay, so this is level 5, and this is about parallelograms. All right, and it's good just to keep track of what unit each one of these is from. So this is from parallelograms. You can go back and review if you need to. All right, and this is asking us about rectangle properties. So what we should probably do is write down the properties of a rectangle here. So rectangle properties, let's put some notes down. Are 1, all angles are congruent, and another way to say that is they're all 90 degrees, and 2, where the diagonals are congruent. Okay, so we just have to look for one of these properties, prove that is a rectangle. Well, let's go through them. First one, diagonals are perpendicular. Nope, that is not what we're looking for. This is a rhombus property. All right, that's rhombus. We don't like you. 2, diagonals are congruent. Well, look at that. We already got the answer. So 2 is what we're going to fill in. Let's just go through the rest of them. 3, opposite sides are parallel. That is a parallelogram property. Duh. It's in the name. And 2, opposite sides are congruent. That is also a parallelogram property. So that was a pretty straightforward one. You just had to know the properties of a rectangle. Remember, you got to remember these properties for the exam. Okay, number 2, we're moving right up. Whoa, what just happened there? We're moving right along. Number 2, if triangle A prime, B prime, C prime is the image of triangle ABC, under which transformation will the triangles not be congruent? All right, so this is just a level 1 question. I'm going to switch off colors here. And this is where you learned about transformations. Transformations. Okay. And so there's rigid motions, and then there's not rigid motions. All right, and the rigid motions, and these are the ones that produce congruent figures, are 1, translations, 2, reflections, and 3, rotations. These all produce congruent images because they are rigid motions. Now, what's not a rigid motion? Dilations. All right, and so dilations is what we're looking for. That is not a rigid motion. Dilations are not rigid motions. They actually make similar figures, not congruent, but similar figures. So that we'll make a similar figure, but not a congruent one. So if we look here, first one's a reflection. Nope, we're going to get a congruent image. 2, the second one's a translation to the left 5 and down 4. Nope, that is also a rigid motion. 3 is a dilation centered at the origin with a scale factor of 2. Yup, that's what we're looking for. And number 4 is a rotation of 270. That is not what we're looking for. All right, number 3, moving along. This is something that we've actually just covered. If a rectangle below is continuously rotated around side W, which solid figure is formed? Well, which level is this from? We should know this. This is from level 10. Level 10. And that's where we learned about 3D shapes. And this is what you should be going over in your head. There's 3 two-dimensional shapes. If you rotate around, you get a 3-dimensional shape. And those 2-dimensional shapes to 3-dimensional shapes are the following. You have rectangle, you have a circle, and you have a triangle. Now, if you rotate a rectangle, you get a cylinder. If you rotate a circle, you get a sphere. And if you rotate a triangle, you get a cone. All right, that's the notes that we want to put down here. So if we're rotating this guy around point W I think it's pretty obvious here, but we are getting a cylinder. Nicely done. Now, number 4, which expression is always equivalent to the sine of x? All right, well, we're talking trig now. So if we're doing trig, we should write down that this is from level 6, where we learn trig, trigonometry, okay? And this is just a simple formula. There's 2 formulas that you should know for this test, okay? And that is the sine of x. Sorry, that is completely, why am I putting the sine of x? Come on, Ben. It's the sine of A is equal to the cosine of B, and A plus B, and remember, that's A plus B always equal 90 degrees, right? They are complementary. And the second one is that the sine of A is equal to the cosine of 90 minus A. All right, so this one says which one's equal to the sine of x? Well, if you go through these, that would be number 1. The sine of x is equal to the cosine of 90 minus x. That's our second formula here. All right, both need to be remembered. All right. Go on to the next one. Number 5, in the diagram below, a square is graphed in the coordinate plane. All right. A reflection over which line does not carry the square onto itself. Okay, that means it reflects and looks exactly the same. So to carry a square onto itself means it looks the same. Now this is from level 1 again. Level 1. This is from transformations. And the only thing you should be writing down as carry onto itself means it looks exactly the same. Now, all we have to do is draw all these lines of symmetry. Now, the first one is x equals 5. And remember, x equals 5 will be a dotted line down like this. All right. Y equals 2, which would be a dotted line across like this. This is y equals 2. And I'm just going to do the third one, y equals x. And that's actually a line with a slope of 1 and a y up to 0. So we'd start here, we'd go up 1, keep going up 1, and your line would look something like this. So let's just take a look right now. Of the 3 lines we drew, which one, if you reflected over that line, it would not look exactly the same? Well, if you reflect over y equals 2, it looks exactly the same, so it does carry onto itself. And if you reflect over y equals x, that also looks exactly the same. But if you reflected over x equals 5, you would get something that looks like this. So it does not look exactly the same. So that option is out. It does not carry on to itself. That is our correct answer. Now, I also want to just graph this guy. To do this, you would have to solve it. And so we'd subtract x from both sides. All right, and we get y is equal to negative x plus 4. All right, now to graph that, you go to y-intercept of 4, and actually you have a slope of negative 1. So it looks something like this. And sure enough, that also produces something that also carries onto itself. Whew, a lot of graph in there. All right, let's keep moving on. All right, we're just going to go up to question 6. This is the last one for this video. The image of triangle ABC after a dilation of scale factor K centered at point A is triangle ADE. All right, so ADE is our image. Which statement is always true? All right, well, this is once again a level 1 question. All right, level 1, and this is transformations. And I'm going to say this. What this is quizzing you on is this. 1, we know that dilations preserve angle measures. Preserve angle measures. And 2, we always know that the image will be parallel to the pre-image of a. All right, so whenever you dilate any sort of line, the image is always parallel to the pre-image. So if you go through these, right, I'll tell you this. Number 1 says that 2 times AB equals AD. And that would be true if the scale factor was 2. But this says we have a scale factor of K, so we don't know that's true. That's out. All right. The second one says that AD is perpendicular to DE. So it's telling us that this is a 90-degree angle. And that would be true if we knew that this was a 90-degree angle. But we don't know that's true. Don't know this, right? It never says that those are perpendicular. So that can't be true. Now, if this was 90 degrees, if ABC was 90 degrees, then ADE would have to be 90, but because angles are preserved. But that is out. The next one is AC is congruent to CE. That would be true once again if the scale factor was 2. And then finally, we have the correct one, which is BC is parallel to DE. And that's because our image, DE, will be parallel to the pre-image. That is our answer. All right, that's it for this video. Congratulations, you've got your first Regents Review video down. Move on to the next video for questions 7 through 12. Nasla Dion, goodbye.